So I'm going to continue giving examples of sets of sentences either having some phi as a logical consequence or not having a given phi as a logical consequence. So for this one, this is a bit more of a familiar example because it's in first order logic. So let's imagine that we have any structure M satisfying this theory. Well, then therefore, M must satisfy every sentence in it, and in particular, to begin with, I want to focus on the fact that it must satisfy P of A. I'm dropping parentheses where it's pretty obvious what I mean. But, so this means that there must be something in the universe. What do we want to call it? We'll just call it A to the M, right? Whatever the structure maps this constant to, it's in the universe of this structure. That's for sure, because after all, every constant has to get mapped to something in the universe. So we know this, and we also know that the element is in the denotation of the predicate P. So this just comes from this fact, just by definition of what it is for a structure to satisfy an atomic sentence like this. And so what we can next do is say that also the structure has to satisfy the for all x sentence. And since we know that we have this as some particular x, then we know that the structure must satisfy if px then qx, where x is substituted for this element, right? Since it holds for all elements, I can substitute this one in particular. And then, continue running through the disjunction, right? Like this means that either the structure does not satisfy the substitution into P of x, or it does satisfy the substitution into Q of x, but since we know that it does satisfy the substitution into P of x, then we can rule out that branch of the disjunction, infer that therefore it must satisfy the substitution into Q of x. Well, that just means that the structure satisfies Q of A. So there is, this is a proof that this theory has this sentence as a logical consequence. Again, I'll repeat, how did I prove it? I considered any arbitrary structure satisfying the theory, and then argued that this structure must also satisfy this sentence. That's how you prove such a thing. Now let's look at a counterexample. So this set of sentences does not there must exist, I claim, and I will construct a counterexample showing that there is some structure satisfying this theory which does not satisfy this sentence. And the structure is fairly easy to construct. All I have to do is say that the universe has some element in it, I'll call it 1, and that the denotation of Q in the structure is equal to the set of 1, and that the denotation of P in the structure is empty. And I leave it to you to check that in fact this choice of structure will satisfy the theory, but does not satisfy the phi over here, and therefore this theory does not have this sentence as a logical consequence.